Verilog. So like for learning Verilog as a student, like it's a good approach. And like there's a lot of material that exists on the web. There's some interesting courses that would be pointing at that basically like does the FPGA equivalent of HelloBoard, which is blink on LED. So that takes you through those few steps using the CI. Yeah, actually that's the last one on the list there. Customize. So if you run through these steps, that should allow you to use the CI system, and that explains how you actually go take a copy of the template of the Cape gateway template, so which is some Verilog code that deals with anything that's attached to the Cape connectors, and then make some very simple changes there that will hijack one of the user LEDs and blink it.
So the Verilog
yeah, so like a lot of renaming, like you copy, rename a few things, and then once you're done with the tickle script, then you are in a Verilog world, which is fairly standard to use. So like it's a nice way to learn how to write Verilog, how to do gateware. So there's one big step that's missing there is the
I found that there's a bunch of nice online tools for learning Verilog. Like, and that might be some useful way to kind of get some initialized, like there's some online tools. I'm trying to remember the names of them, but you can actually run simulations online in your web browser, right, to simulate something like this. Kind of like like JS Fiddle, if you've ever done websites, or I'm trying to remember which tools. Do you remember the names of them? Because we should really put a link here.
Yeah, so like there is
for the first time.
Yeah, so like there's one aspect is learning Verilog, and the other aspect is doing verification of your Verilog. So there is, I've been looking around at the existing courses, and there's one from okay, I'm not going to try to pronounce the name because I probably won't get it. Basically, like the guy who wrote the Zip CPU, he has a very good course, like a set of slides, and you take them through, and if you take those slides in parallel with this, it will actually take you further from from just blinking the LED. Like it will try to different patterns and go a little bit further from that, starting from that little example. But more importantly, it explains how to use Verilator to use C++ to write a test bench for your Verilog, and that's really the key. The key thing that's not yet in that documentation is how, and in the Verilog template is the C++ test bench template.
Yeah, C++, or a lot of people just do it with system Verilog these days, right? I mean, you could do it with C++, or you could do system Verilog for your.
So like there's many ways to do it. So the nice way about C++ is that it's already more than likely already on your machine.
So the one thing that wasn't super clear from what you guys explained is so does the Debian package actually, so it contains the Verilog, how does it actually deploy to the FPGA? Does it just is it a callable function within Linux afterwards to actually then it just runs in the background, or how does it?
So the Debian package only has the updated firmware and the flashing script. So Microchip has written there's a Linux driver that we use where we move the firmware into the right spot. We hit a certain magic area under sys. It'll actually program the FPGA and then reboot. So there's always going to be a reboot involved. But yeah, so all the deb packages just have the firmware stuff, and it's up to the end user to run the Beagle version command, see what version of the firmware they've loaded onto the FPGA, and then compare what they downloaded. And if it's diff, they can update it and then essentially reboot.
Interesting. Okay.
So yeah, it's I don't know, Cyril, has it gotten to mainline yet? I know
so
Connor's working on it. But
yeah, so Connor has done, so like the version that we have is actually not Connor's first version, because the first version was risky and we actually managed to break a few boards using that approach. So this is the second approach, which works quite well. But like it's still a little bit messy. So Connor is currently, well, it's not that, I think he's actually has it rewritten and he's going to be resubmitting the drivers for it into mainline.
that's awesome.
So, yeah, so like we have, Connor has had some difficulties with that code in getting it into mainline, because the PolarFire SoC FPGA is a flash FPGA, so it doesn't really follow the model of the other guys, which are SRAM based. So we don't fit in the standard FPGA manager approach of doing things. So like Connor did something else that will be even cleaner. And from a point of view, like from a user point of view, like we'll just update the script and the script will just use the different approach. So like this set of instructions will remain the same regardless of the switch of FPGA programming details in the Linux kernel.
And then we got, because of our design of this SOIC, this PolarFire, we got to be a little careful too, because in that FPGA firmware, it's also the HSS, if I'm correct, right? And then all the details for how the RISC-V core complex actually talks to everything. So if you misflash it, well, you've soft bricked it so you can re-JTAG it.
Yeah.
So it's extra careful.
Yeah. So that's one of the things that the gateware build system is.
It's building that interaction.
It's built to actually not get yourself into that situation.
Yep.
And like, but you will be able to break the board. Well, you will not.
It's like soft brick. Yeah.
It's soft brick. Like you have to be very creative to break the board. You can actually get the board, if I remember correctly. Yeah, we do still have that stuff. You can actually get the board to self-destruct if you really want to. But like those features, like on with those macros in the FPGAs, I've made the conscious decision of not using them, so that it's pretty safe to go modify the gateware without really. So you shouldn't really be able to really break the board. Like you really have to go be very, very creative and probably restart doing a gateware from scratch to break the board.
And that's where Connor's driver is so important. I know a lot of other FPGAs, they usually bring up the ARM first, and then the ARM loads the FPGA. In this case, it's like the FPGA and it's everything. So it's like, the firmware updater has to be very special.
So I have managed to soft break myself recently. So there's really the easy way to soft break yourself is to mess up the device tree overlays. And the one thing to do is to include the PCI Express block in your device tree overlay and not actually include it in the gateware. At Linux, when it boots up, it goes looking for the PCI Express block and it goes into La La Land. And at that point, we can't get back to Linux.
And to be fair, we can do that in
a serial cable. You can fix that from a serial cable in the U-boot prompt. You can actually avoid that so with just a serial cable, you don't need to redo the flash on the SPI.
So
in order to boot from that sort of overlay issue, because you can change what the overlays are at the U-boot command line. So that one requires a serial loader. Only when you've done really nasty things do you need to go and get something like the Flash Pro 5 and the Tag Connect. And then even then you don't need the Flash Pro 5 if you use the
Beagle in black with a direct C cable.
Direct C. Right.
So
we've got in the Beagle Fire right now we've got right,
it's the middle there, direct C.
So it's in the direct
C right there.
So that direct C stuff is something that has existed for years, like for more than 15 years. It's been used very little But but it's actually extremely useful in the case of the Beagle 5 Fire, or actually any other. Using this software, you can program a microchip FPGA from nearly anything.
Mm-hmm.
And also, if you don't have, and that's question that came around the forums, is that if you don't have a Flash Pro 5, there's also that very small device that you can't get from Trends, which is a clone embedded Flash Pro 5, which works fine.
That's awesome.
So that's another approach. So when you look at the cable, like it's you can hardly see it compared with a Flash Pro 5, like when you plug it into the cable. So there's different options, when you want to go into that world.
So the most
Also, I
expensive
wasn't
part
aware
of
that
that
they
ends
had a
up being,
clone.
yeah, the most expensive part of it ends up being the tag connect.
Yeah, the Tag Connect cable is the most expensive part.
Yeah. But
of that
if you're willing to go that hackery at that point, you can also just solder to the test pads and.
Yeah, but like when you look at the price of it overall, like it's, if you want to use the Tag Connect, so if you want to use the Tag Connect, if you're using Linux, you probably should never need to have to use it.
Yeah.
If you're doing some bare metal, or if you're hacking with RTOS directly, then it does make sense to have the JTAG port. And if you want to do some fancy FPGA debug, then you use the Tag Connect. Like, for example, like generating DIs for the SerDes. That's where you need the JTAG port. But like most of the time, you should not need it. So like just with the board, you're good. Like you can get a lot done.
If you're a broke college student trying to, fix your soft brick FPGA, just bust out the soldering iron, bust out your BeagleBoard Black, or borrow a cable from a professor.
Borrow the cable from the professor. Get the professors to give it. Yeah, maybe we should give every professor a free cable, and have that problem sorted.
That's possible, and we can, if there's a professor listening to this, we will ship you cables. That sounds like a good use of. So I just wanted to share this. This is a taking Blink code and a kind of quick and dirty test bench in System Verilog. All right, and right now this one's not graphical. I'm sure there's some other out there that will do nice graphical. This one here is just searching for the eggs and printing pulse. Right, but this will compile your Verilog code and test that. Oh, okay. So it'll compile your Verilog code, and then
You might have to repeat that, Jason. You were breaking up a bit there.
So the EDA playground's pretty nice because you can just run here it'll compile your Verilog code and then run the System Verilog test bench. You can see here it's what detected the pulses, right? It's on the blinky LED. So I think it's a handy one.
Is this using just like open source, like iVerilog, or what's behind the scenes on EDA program background playground?
Well, it looks like it's brought to you by Duolo, so you could probably ask them.
Anyway, Cyril, do you know a better like I know we could use Libero to do the simulation.
Yeah,
and
no,
I'm looking for as much open and easy and free and.
Yeah, so like there's a couple of those.
I mean, I think Libero is free as well, but it's
not.
Yeah,
Libero is free, and but okay. you can use Libero, and you can go create some test benches that will make use of QuestaSim. That's a perfectly valid way of doing your test bench. Like everybody has kind of their preference. I really like using Violator. That's I found that for me that works very well. That does what I'm looking for. So like I'm basically like writing my test bench in C++, and I can write something that will generate traffic or something that will observe the output of my circuit and write checkers in C++. So like kind of analyze protocols and write some analysis in C++. Whereas like I would not know where to start, how to do that in QuestaSim. But then again, my background is not digital design. So like somebody who's has a digital design background will run to Libero and will be very comfortable using this. But for somebody with a software background, I think Violator works for me as somebody with a software background. And like, since like we're trying to say that, hey, this is not an FPGA, so we should have a big bunch of software people, using these boards and have them in their comfort zone with C++. But like, there's many ways to do things. So like, there's the Violator, but like, there's also something that I find very interesting and very valuable from the point of view of verification is formal methods. And for this, YOSYS does have some features there. Like you probably, if I was doing this professionally, I'd probably be using a mix of the two, of Violator and YOSYS. Use YOSYS or Symbiosis for the formal verification aspect of it, and then Violator for like the simple protocols stuff, or like the functional testing. But here again, like, there's some
It's
people who be listening
Symbiosis.
to
Is
me.
that the one you're
Sorry?
talking about? Symbiosis. You're talking about symbiosis.
Yeah. Yep. So so these tools can be used for synthesis, but for me, where for me, the real benefit of that toolchain is the formal verification. Like the synthesis, synthesis can be done with the Libero tools, the supplied tools. That works fine, and it's quite efficient. And you could probably use this for synthesis on Podify SoC. It'd be interesting to try out to see how far you go. But for me, like, it's the added feature, like, beyond the synthesis. It's the formal methods. And here again,
Cool.
I can't remember this name. Like, if you look up Zip CPU, I do believe that he also has some introduction to formal methods, which could be interesting.
What's
people
CPU?
to learn
Zip
about.
CPU? What did you say?
So yeah, Zip CPU. What is it?
I'm happy to let you share, and I'll turn mine off.
Yeah, go zipcpu.com. Yep.
They don't. Somebody needs to teach them about HTTPS. And let's encrypt. Let's encrypt.
So so if you go into the tutorials, and you can actually run through the entire tutorial there. Like if you want to learn Verilog and how to do test benches, like it's a very good, like that's one of the best free resource that I've come across to learn Verilog, Verilator, and formal verification. That's a very good start. So there's a lot of material that's available online that can be used, and this is a good one.
I think what a lot of people would be interested in doing with the Beagle 5 Fire is like taking very small RISC-V cores and getting some extra visibility inside them, simulating them, right? But getting something that goes fast enough, right? So you can do the offline simulation, right? But you want to run it in the FPGA fabric to get something that's able to run, and then like connect up to outside hardware, but at the same time have this Linux system that can go in and monitor that, right? So one thing I'd like to kind of spearhead is kind of bringing people together to kind of put that, kind of tutorial system together where you can have a synthesized tiny stimulate that with different IO, right? Maybe do some things like what we had with the PRUs. So you had some directly IO mapped bits in some of the registers, and then you'll build out some additional visibility from the Linux side, right? So that you can look at the memory that's accessible to that RISC core, look at all the registers, right? And, we have a lot of that with kind of stop mode debug, right? But with JTAG, but you have when we're typically doing Linux debug, we're looking at doing runtime debuggers like GDB, things that like do software trap based debugging, right? So you replace the instructions with things to go into the software, and then you go and look at the registers. I think it gets kind of interesting when you've got the ability to kind of instantiate a CPU that you're not kind of limited to just JTAG scan to kind of get the access to all the internals.
And Jason, that reminds me, we got to submit a core score to Olaf. So how many RISC-V cores can we run on the Beagle Fire while still doing normal stuff?
Yeah, that's a great point.
Because I know the
so we'll have to...
Icicle is on there at 882 core score, and a lot of our FPGA fabric is kind of being utilized. But yeah.
Yeah.
Yeah. So core score.store has the whole list. So Olaf, one of the designers of a lot of the RISC-V CPUs, put this out, and I believe he has a board.
Did a very tiny. All right, he is one of the tiniest cores, right? So.
Yep. Yeah, if you go scroll down and go to the
cores we can put on a Beagle 5 Fire.
Yep. And what I like to do is when we do that, we should have each core doing like a pair of pins or a single pin, and so that way we do some really fun IO. But yeah, Polar Fire 882 RISC-V cores. So we're a little bit smaller than the Polar Fire eval, so it'll probably be.
Oh yeah, lower. So the Polar Fire eval kit, if I remember, is 300. It's a 300 part. So yeah, so
we should be 10 times less. That's still 80 cores.
Yeah, still like 80 cores. Yeah, so like still 80 IOs to play with. With some interesting stuff.
So in the bottom of the yellow range is where we guess we're going to be.
Yep, because we're the smallest of the Polar Fires, and we have a lot of stuff being taken up already. So
Fun.
Because I assume that we run this score that we're still running Linux and we're still talking to it, so it still has to boot up Debian. So,
Although that doesn't take a lot of gateway resources necessarily. There's some of it, but like a lot of it's in the hardwire portions, right? So I mean, there's definitely some resources used in the routing, right? But I mean, I don't know how much of that is like, if you look at something, it's the MSS. I forget the H. I get confused by some of the acronyms, the abbreviations.
There's the MSS, there's the HSS, there's So like the MSS,
but the MPU subsystem, and so there's the Heart System Services. That's HSS?
Yeah. So the
And
HSS Heart Service routine is like your 0-stage bootloader, plus that's really the code, the first piece of code that executes on the processor. Actually, that's another small weird point, is because of the flash that we have on this device, we do not have a boot RAM for the application processors. So you can basically, like, DHSS is the first piece of code running on these application complex. So like, if you want to do your own flavor of bootloader, like it's an interesting platform to play with. So like, that's the HSS, Hard Software Services. The MSS is the microprocessor subsystem. So like, that's all of the ASIC blocks. So that's the 5 64-bit RISC-V processors, the peripherals, your Ethernet, your USB, all that stuff, and then the rest of it is FPGA.
Yeah, because I don't think we need a whole lot of the fabric. We have to do some configuration of the HSS and the MSS, but I don't think we eat up a lot of the fabric just to get our system to boot, right? So I think that it's a hard controller for the eMMC, right? So that's coming out of the MSS. That's really not coming out of the logic fabric, right? So
yeah, and like you can. Okay, so in theory, I'm not sure if it's really that useful. You can, like, well, yes, you can build some systems that make sense. You can start up you can use the MSS, you can use the RISC-V without having anything in the FPGA. And I ran into a question from one of my colleagues, like in the week, like, we're looking at the reset structure of the device, and we kind of came to the conclusion that yes, it's it has its own clock inputs, and like it generates its own clocks, its own resets, so the processors can start on their own without the need for anything in the FPGA. And yeah, if I remember correctly, that was one of the requirements for that device.
that makes sense. I mean, not that it'd be strictly required for all use cases, but like having it have that flexibility. All right, there are so many useful hardware peripherals, being able to just use those hard peripherals rather than the fabric, right?
And I think what we're trying to
useful
get from this too is we're thinking, like, so when I say PRU, in this case, I'm actually meaning RISC-32, but so in the BeagleBoard family, we've always had devices with PRUs, and you have only a certain number of pins and a certain number of PRUs. With this board, we could make unlimited PRUs for like every 2 or 3 pins. Each has its own dedicated little CPU, and I think a lot of people would see that as a really nice way to do real-time I/O pretty much on anything. The question is, how big does each RISC-32 have to be? How many I/O pins does each need? What peripherals do we need to add? And
yeah, so that's when we've been, that it was, the PRU approach is a good approach in general. Like with the FPGA, we'll probably find that for some of the stuff that the PRU would be doing, if you actually did a Verilog design, or like a very small block, you'd probably do fulfill your function with a smaller part of the FPGA of the logic. But yeah, like you're right. Like on the BeagleBoard, like if you're seriously taking PRU, and if PRUs are not a problem for you, but like you need more, you need something slightly different. One way to think about the Beagle 5 Fire is that the difference is that there's some a different kind of PRU on the system. And the way like some people use the BeagleBoard without going anywhere in the PRUs, you can use the Beagle 5 Fire without going very much near the FPGA. Like you can use the pre-CAN designs that we provide and do that, or you can go deeper down the FPGA route. So it's it's different way of solving a problem, and like it's down to what your preference is.
Yep. And I think all we're looking for is like a simple RISC-32 core that is really fast I/O, essentially. So like it's PRU like, but no, it's like take a RISC-32 core, throw in like 8 of the I/O, and then have 12 of them on the Beagle V Fire.
I'm going to use that as an opportunity to switch directions a little bit and plug GSOC because it's GSOC time. We can start beginning to submit our organization applications this month, right? So it's time to put together our case for why Beagle should be a mentoring organization for 24, and then this is perfect for ideas, right? I think we're trying to move away from using the eLinux wiki, but we really haven't made that transition. I think it's worthwhile to figure out how much of it do we want to put on OpenBeagle, which is our GitLab server, and how much of it we want to put on the forum. But essentially, I think we're going to be moving everything to one of those two places, either to our forum or our GitLab, right? The OpenBeagle server. Losing Andre is always scary because he's the guy recording all this. So,
oh, still here.
Yeah. So I don't know if there's any feedback there. Are we going to move everything one way or the other? But we'll be working that out, in the chat and in the forum over the next week or two to try to make sure that our guidelines are really clear, right? I think the ideas template is largely going to be the same, right? But maybe we move that into OpenBeagle.
I think the biggest thing is this is the first year at GSOC where we have an FPGA design that people can utilize too. I mean, last year we were close, like depending on how things go, but it kind of brings an unlimited number of possibilities for students to work on. It's like, what do you want to?
Yeah, we had some added as capes in the past, right? But like, and we actually did some legwork on the whole idea of implementing PRU, right? Which by that I just mean a CPU with I/O mapped to register bits, right? So directly into the register bits, and I think that would be one of the first proposals I'd like to look at. But I think also if we look at a bigger project, maybe something that does a deeper visibility to a RISC-V core, right? In there, not just getting the PRU bits going, but something that's a little bit more of a CPU building tutorial, and just overall improving that developer experience to get started doing Verilog, quick and easy for people. I think that because we have a working Linux system that people can just start from and just start forking designs without doing CI, and but just using CI with having to install a lot of tools, right, opens up a lot of possibilities for making this a lot lower barriers to entry.
And you're not I/O or throughput limited this time, right? Compared to a cape or something like that. So you have that fabric.
Yeah. I mean, because you've got direct access to the DDR, and then you've got the PCI Express and the extra SerDes lanes. It's worth talking about the work that Charles Steinkuhler started, right? So the all right, Robert, what's that called? The Ziggy KiCad. You're muted.
Yeah, I can never figure out how to pronounce it. Ziggy or yeah, but Charles posted in the forum. He's been working on interface board between the BeagleFire and. Oh, you got it up. Yep. So yeah, here's an awesome project. Ziggy's KiCad, and he's also sent boards to Osh Park, so people can buy them now.
Is there a picture up?
If you click the Osh Park link, it should give you a rendering.
Yep. Click the Osh Park link. Otherwise,
did he give an Osh Park link?
Yep.
Yeah, it's
Does this do previewing of STP? No.
You got to use there's a KiCad viewer that one of the developers writ. KiCad Canvas should work on it. Oh yeah, or just bring this.
Oh, nice. There we go. That's what I wanted. That's exactly what I wanted. So this is the Ziggy connector, and now you've got mounting holes that are more aligned with the Beagle 5 Fire, right? So,
and he has the communication.
3 SerDes lanes. What do we have on the? We have three separate SerDes, right, going to the Ziggy. Is that right, Cyril? If you remember.
Yes. So there are 3 SerDes brought into the. So I think I've heard people pronounce it Ziggy. Actually, I'll give up on the pronunciation as well. Like it's. So yeah. So there's 3 SerDes lanes that are brought to the header. So there is one caveat is that. If you're using PCI Express, so if you're using like a Wi-Fi module on the M.2 connector, you can only use 2 of the SerDes lanes. So there's something like, so if you want to use all 3 SerDes lanes, all 3 transceivers for these boards, for this interface, you need to disable the PCI Express block from the gateway. So like it's a little quirk of the PCI Express and the way the transceivers are organized.
I'm pretty sure Charles wants to use that. That's why he just brought out the 2 in this design.
Yeah. It's pretty cool.
Did he only bring out 2?
Or yeah, just
is that the case? He only brought out 2.
Yeah, that's only why there's 1 pair on this image.
I think it's pronounced as syzygy, which actually means a pair of connected or corresponding things. Maybe how we are using like a lot of SerDes pair or something like that. So that's why they chose this.
What's the intent for it? For doing SDI? Is he trying to do video output or? Because only SDI is a video standard, right?
Yes. So we would have to ask Charles.
Yeah, I was curious. I haven't actually seen the forum post yet.
So analog video being seen?
I think SDI is digital.
Oh, is it? Okay. So like I won't look it up.
It's like a broadcasting. I think it's used in broadcasting normally.
Yeah, I think it's used in professional video systems.
Interesting. So he might have a use case there. I guess copy stuff out of frame buffer, output it, copy it back into RAM. Maybe DIY capture card.
Yeah, so I've seen some people do interesting stuff with this. So, for example, when you're watching, okay, you guys will be watching probably different sports. Let's say you're watching, football, and you see a line appearing on the pitch to show like which way the players are aligned, and that's done in real time. So I suspect that that video goes through an SDI interface into an FPGA that then overlays some video real time onto before it goes back to the broadcast. So that, you know, those type of applications of professional video of real time manipulation and overlaying of you know, information on video before it goes straight into the broadcast.
Yeah, it seems there's pretty affordable HDMI to SDI converters, right? So for $40, you can get an HDMI to SDI converter, but like the SDI, it must be used in more professional situations, like you're talking about, right, where you're you know, doing live video editing with hardware. I think the retention seems to be one of the quoted benefits to it. The fact that you have a screw cap on there so that people don't, you know, if it's absolutely required, you're not bumping into the cable and disconnecting it over HDMI. I'm not sure what else is really better about SDI. Explains to me why I don't know that much about it, because I'm not that much into broadcast video. But that seems like this board sounds like we could do some cool demos.
Yeah. So I've come across a couple of other boards. I think Jason, you got a couple of boards, and okay, where did I see that stuff? Okay, so like there's a few boards that for A2D converters, high-speed A2D converters and D2A. So like there seems to be a few options there, and I've come yes that type of stuff. So I've come across something that was less than $100 for A2D D2A somewhere. So
using syzygy, or
yes,
just
yeah, using CGG. So okay, I can't remember what's in it, but yeah, like if you do a search, probably come across it on one of those popular electronics merchants sites. So yeah, so like that interface is quite interesting. So I was not familiar with it before the Beagle 5 Fire. I suspect it's fairly recent, but yeah, that does open a lot of opportunities to like, I'm thinking like software radios or things like that, where like it's one can probably do some very interesting stuff.
That could be another really interesting area for the GSOC stuff, right? So how can we, you know, do some tighter integration with stuff like GNU Radio? You know, some, you know, are there certain pieces that we can put together for folks, you know, to give them a platform for doing software-defined radio a little bit cleaner? I think that's something that is worth some project proposals, right? So this is continue to call for people who are interested in mentoring really high quality students. We get some really great students every year at high quality universities, and right, a lot of them are master's students with some really great backgrounds, right? So we really get great students, and want to encourage mentors to kind of get their ideas out there now, so that we can present them to attract the right students and make the coolest projects, right? That where people can, and I will remind would-be mentors, it's not about doing the work for you. It's about, you know, creating reusable code for the open source software community, and not to encourage kids to do cool what I did over my summer vacation projects. It's to actually make reusable open source software, right? That's the end goal, right? I think people come with these crazy ideas of things that would be really super cool demos, but a demo is not a reusable software component that people will, continue to support and live and moves open source software forward. But we've had some really cool stuff. I keep looking at all the stuff that came out of the work to put ArduPilot on Linux, right? I think, that continues to just grow and grow and grow. And that started as a Beagle Google Summer of Code project. All right, too much me.
So I guess, Cyril, while we have you, any fun projects you've been working on? Because you've kind of teased that you've been doing some fun kind of things on your own time, and I'm just curious.
Oh,
if,
yeah.
you'd
So,
like to share.
okay. So I do like CNC machines of different kinds and that type of stuff. But what I'm really big into is model railways. And there is actually a protocol for controlling model railways. And I have, a fairly decent setup, but yet I'd like to do something slightly different. And actually, it's funny because the reason I got involved of this was for that project, because I could never find the board that would fulfill my requirements. A little bit of FPGA, a processor, reasonably priced, available forever. So that's why I got involved in the Beagle 5 Fires, is just purely for me to get some of those boards to do some of those projects. And like the model railway control is one that I will get back to, but there's quite a lot of documentation that I need to put in shape and give to Deepak. Little bit more CI work that needs to be done with Robert, but like eventually this is where I want to go to with that board. And that's only one project, but that's the more that's one that's I would put that's reasonably achievable given the amount of time that I have to put into it. And that could be useful for as well.
And you could probably do a lot of it, but if there's the reusable building blocks, right, getting protocols down, these also make really good Google Summer of Code projects, right? Building out. I'm sure there's a ton of management software out there. Integration with ROS and doing the visualizers, right? So that people can do quick track builders and simulators, path planning, right? There's tons of real-time problems to solve.
Yeah, ROS is also one topic of interest for me. Yeah, but there's not enough time. That's the problem.
Well, ROS, that is why you mentor somebody and who has more time than you have. But could very much benefit from your expertise, right? So you spend, maybe dedicate an hour, or hour 3 a week, right? And if you can get 3 hours a week and they can put in 40, you can get a lot done that way, and the open source world will thank you for it.
And the nice thing about ROS is there's a lot of educators working on it. I'm pretty sure they have students that are
need help. Those kind of make sense. Yeah.
So there's people working on it. It's just more like, because ROS is so big and massive. That's one of the problems with
it. Somebody still has to. I haven't spent much time with ROS 2, right? I mean, ROS is big because it's got a whole bunch of different blocks, but I still get a little bit lost on the simulator. I think is really cool. Like that's one of the things that I really like out of ROS. But overall, it's like the original ROS just seemed to be very focused on how do I get people that don't know proper code structure and how to design code properly to isolate the different responsibilities of a job and create message passing so that I can do appropriate scheduling in the different scenarios. And yeah, it's just about all of message passing architecture and writing isolated structured code. It's like, did I really need ROS to do that? Well, I guess it's just about who you're collaborating with, because you're talking to a whole bunch of people that don't know how to do that.
And this also brings up the question: is ROS they add RISC-V as a supported architecture yet? Because they are in the ARM and ARM64 world, but
actually, yeah, that is the no, yeah.
let's see.
No, you can run ROS on RISC-V. Yeah,
Yep.
somebody has done it. Yeah.
Because one of the things they have is they have their own package repo too, where they build everything, and it's easier if you use that than try to rebuild everything. So it's nice when they officially support an architecture. So like
Well,
on the,
I mean, whether or not they officially support the architecture, they do officially support the operating system, and that's going to mean a whole lot of less software dependencies to worry about, right? Because it's on Ubuntu, and guess what? We're on Ubuntu, so you'll have the dependencies covered.
Yeah, because we ran this in the problem of the ARM world. On ARM32, they only officially supported Ubuntu, so we always had a special Ubuntu image just for the old Beagles. Well, this will let you run ROS, because you didn't want to try to run it on Debian. Let's see, target platforms. I need to go through the review notes and see if RISC-V is now officially supported architecture, or it's being...
Hmm.
2020 hasn't been updated, so okay, maybe it's still ongoing. Yeah, because we ship Ubuntu out of the box, so as soon as ROS officially supports RISC-V, then it should work. It should be installable.
Yeah, could be an interesting weekend project for somebody.
I'm finding a bunch of scholarly articles about this. So good GSOC stuff.
Well, I think we are around time anyway. So, Jason, do you still
Agreed.
have other topics, or are you planning to? Do you want to?
There's a couple things I want to plug, right? Which is the we did a webinar on BeagleFive, which I think the biggest thing that came out of that was a set of flashing instructions, and particularly like kind of how to reflash the BeagleFive ahead and the BeagleFive Fire, right? So I kind of walk through the processes of like flashing an operating system onto each, right? Getting them into the bootloader, getting them into the place where you could flash them. So those webinars, and I'm sure we'll link in the show notes somewhere, but those are on the Element 14 stuff. And then what other things I want to make sure we didn't get out of here with? Andre, I hear you've got some Zigbee stuff running in your house. Is that right?
Yep, I have motorized blinds integrated into Home Assistant with a Beagle Play that's been running for I think 4 months now. Just nice and stable. It's actually in the craft room behind me, so we'll talk about that soon. There's a tutorial series, that kind of page that explains how to do it. There's a ZNP firmware you can flash on the Beagle Play CC1352. So you don't actually need any external hardware beyond your actual Zigbee accessories, and they all mesh together more or less reliably. The stuff that doesn't work is more Zigbee's fault than the Play. But yeah, it's cool. It's been reliable. They work pretty great, and it's fun because you can get them at IKEA. So it's they're pretty easy to get if there's an IKEA nearby, or yeah, just get these blinds that are all on their own. I still need to do some fun automations, like based on the time of day. I still want to have one blind go on, one blind go off, just so that the sun doesn't blind me. Kind of what Robert's dealing with right now, but.
It's the only chance for vitamin D right now, so I'll take it.
Yeah, we'll talk about that more in the future one, I think, and maybe we should do a video on it because that's a fun one.
All right, so maybe in the future we'll talk all about Home Assistant and Zigbee. That sounds cool.
Yeah, with your BuildRoot integration, that's gonna be even better.
Yeah, the builder stuff, right? I was able to just go and easily build the mainline kernel, right? So now I'm just waiting. There's a the mainline kernel. Just edit the distro boot, right? Boot init ramfs, right? I mean, it like was easy to come up. Like it was really trivial without any kernel patches at all, right? Just running mainline 6.6. Was that on? Is that right? No, it's not 6. 6.3. Is it 6.6 or 6.3? Now I'm blanking on it.
Yeah, 6.6 is a pretty stable image on the play. It also U-boot mainline master now supports the play out of the box, and so that is now in the bookworm feeds. So the Beagle play is actually running mainline U-boot on bookworm.
Hooray!
And so the AI64 will follow it, and RC1, because that just got merged yesterday too from Next to Master. So the next RC1 of U-boot will be the AI64 also switch over.
Yeah. So running the builder stuff off of all of the mainline stuff really makes it a lot nicer, right? So the patches are cleaner. I'm not like doing a whole bunch of out of tree patches, right? Just taking everything from upstream, right? So that's pretty close now with Beagle Play, so we can submit it to Buildroot. There was some work from a TI guy as well to put the AM62 stuff in there, right? In general, so adding the Beagle Play is going to be pretty trivial. And
speaking
of
GSOC, a lot of patches, right, for Zephyr.
Yeah. Yeah, then also, since we're talking about U-boot in the Beagle Play, for a GSOC project, the video subsystem does exist. It's just not the encoder for the play. So if someone wants a BIOS screen on the Beagle Play, it just needs the Linux driver. We're one driver away from the Beagle Play having a boot screen, U-boot or a Grub or BIOS or EFI on startup.
Yeah.
That is
since the last time. Yeah, since the last time we had one of these. A BeagleCast, right? We've got the mainline. We now have Mesa support upstream and a fully open source user space for the GPU on Beagle Play. I think some of the integration bits to kind of demonstrate it for people are still missing, but it's there's now a full open source Mesa user space for Beagle Play GPU.
Yeah, the basic Vulkan tools.
Get the U-boot EFI, like it'll be just like everything mainline open. It's just going to be incredible.
The dream there. It's getting there.
Nothing to add to that, Robert. And yeah, you were talking about the Zephyr stuff, right? So we're getting the mainline Zephyr support updated for all those, including the gray bus stuff, right? So been good progress since the last time we talked, getting all the kind of the dependent bits for all the gray bus stuff upstream. So
yeah,
still some
gray
ways
bus
to go
driver
there, but now
it's like the gray bus driver is mainline, so we have that now. He's been doing awesome. It was a speaking of GSOC students, it was another GSOC student that wrote it. He's still working on it, and he's doing an awesome job pushing stuff to mainline from Zephyr to Linux kernel. I can always mispronounce his name. Oosh. Yeah, he's doing an awesome job.
Yeah, and you guys announced Click ID. That's another thing, I guess. There's just a lot that's gone on in the past little bit. So we have a lot of things to cover.
Yeah. Let's not be so separated. Like, let's make sure to try to keep our cadence up this time now, because we will. Always stuff going on in Beagle land.
So that'll be another fun one for Beagle Fire, is how many microbus sections can we put on it? So that way, because each one will have a peripheral dedicated to all the options of microbus. So how many of those can we fit on a Beagle Fire?
Okay, yeah. So funny enough, I have a cape, a click cape with 4 slots on it, and I'm thinking 4 slots is just not enough. Like you could put a good few more on those.
So what do we have? 48 pins available on
yeah,
the fabric.
Just area-wise, you could fit at least like 16 shuttle ports.
Yeah. I mean, it's just be a Beagle with all the little shuttle connectors on it. Each one, everything's fully independent, so you can have as many I2C or SPI devices.
Yeah.
Put two of the full microbus connectors, and then the rest of the space just fill it with shuttles. Actually, you could fill the whole space with shuttles, so I don't know.
imagine like every of those clicks will have its own dedicated PWMs, I2C, SPI, UARTs, and a little RISC-32 microcontroller to do the communication. And yeah,
That might be really nice for like a for us to do for like a regression test bench. That's actually a really good idea because we can kind of make sure the software is running with all the clicks on one board. So that's actually that's actually really interesting. We might be able to have like, if we take 5 or 6 of these, we might be able to test like 200 clicks at a time.
That's not a bad GSoC idea either.
Yep. Think about the driver to about, look, we got 200 different clicks connected to one BeagleFire.
That's a very kite-catable board, so.
Yeah, I love it. I'll implement them. I'll put a bunch of them in my CI over here.
Priorities. What do we say no to?
We don't know the definition of no.
That's a good problem to have.
That's the problem, yeah. I was actually going to ask the last couple of weeks, like if we had a list of clickboards that one would recommend that should really work out of the box to actually test something similar to what Robert was describing. So that I could
Jason
actually...
So Jason does have a list. It's like 200 some, 300 some that Vishnov had done a few years ago, and I think Deepak worked on some of it too after that, on some of it. But yeah, there's an unofficial list of all the ones that had worked.
Mm-hmm.
Yeah, I think we still have that task, Jason, of condensing it to like 10 or something, right? That are.
But I like the idea of
yeah.
If we take a BeagleFire and just have 100 of them connected, we'll say, "Oh, these all work," and just keep on building them. Yeah, there it is. Yeah, so they're the Click ID database, the Click manifest.
Okay.
Tutorial. So these are the ones that we did manifest. These are older, but this is like, well, they're not. There's newer, older clicks in here. I'm just saying we did this a while ago, right? So yeah. There's all of these clicks that we have manifest files that should just work with the manifests. But as far as the ones that include manifests on them, Click ID, I gotta pull up that page. So if you look at ones that have the manifest loaded, it's not Click ID. Anyway, this is, if you have these, it's just a simple one-liner to get it. Do you have the link to the microbus page for Click ID?
Nah.
Is it Click Dash ID or Click ID? I thought it was just Click
/Click ID, one word.
Microe.com/Click ID. Oh, it is microbus/Click ID. I don't know how I missed that. Is this? Yeah, so there's a whole tutorial here. There's a video here showing how using Click ID with the Beagle Play, and there's also this list of boards that's recommended. Where is it?
Yeah, because all new boards coming from them have the ID, so a lot of
right. But just because they have ID doesn't mean that they have a manifest, and that's the important thing to keep straight. I thought they were here.
It might be on the GitHub page.
Oh, that's the video. So because there's a so the ID and the manifest are not the same thing. So the ID just tells you what the click is. It doesn't have the extra meta information for what drivers to load exactly. Like, so all of the driver loading information that we provide in the manifest, right? So this is the manifests, right? So if you have the manifest, you can get the driver loaded and everything just works. You can store these manifests into those EPROMs. You can write them into it so that on next boot it'll come up. So so there's just an extra step of actually writing it into the EPROM the first time. But there's about 15 or 20 or so that come with the manifests already in them, so that when you plug them in, they just boot right up without doing any manual active at all. And getting that official list, I think our biggest challenge has been who owns that, Micro or Beagle. right? Because we both there's a dependency from both sides, and so neither one of us, I think, has been like 1,000% comfortable, right? Because I say it's their responsibility to publish the list of ones that just work, and but they rely on our software to do that. So that's the impasse.
Yeah, the fun thing is Micro is so quick on new clicks that a lot of times these exist before there's any Linux or even manufacturer drivers. So they'll have a board spun and ship thousands of them already. Oh yeah, we need a driver for this. And so it's kind of a chicken and egg problem. They are so quick that there's no driver. And then once we get a driver, we can update the manifest.
Yeah. This is exactly why I'm asking the question.
Yep.
Because like they have so many and they keep making so many, like it's
it's like one every other day. It's constant, new one, and it's always new silicon that no one's ever seen before. So
my goal is to teach them to write Linux drivers and submit to them to the mainline ahead of releasing the boards, right? Because they do their own software, right? And we've talked about doing a HAL to a big extent, but HALs don't ever make it into the kernel, right? So you could do something that's compatible with their what do they call their software?
Something SDK.
The Necto Studio.
Yeah, the Necto Studio uses it directly.
Necto. So you could so you could potentially, whatever their SDK comes with, you could have a Linux house that you could just run that software as is, but that would never be mainline, right? Linux is the abstraction in Linux, so
their Micro SDK 2.0,
anyway,
they call it.
We'll get there, so that all the boards shipping at some point will just automatically run. But for now, if you just write, if you buy a board with Click ID and you write the manifest to the EEPROM, it'll boot up and run. And feel free to submit more manifests to us.
Yeah,
they're not too hard, but I think we're working on documenting that process on how you create a manifest easier. So we need to get back to that, Andre.
I know. Yeah, I was gonna say. I think that goal of at least having a couple that are known good pre-flashed plug and play experience is the Q1 goal. So early Q1, not Q1, just early. Next 2 months, I'd say.
Yeah, I've been surprised. Like I had a GNSS device that I plugged in and was like going to try to create the manifest for it. And I realized that the driver was already loaded and running because the manifest was already there. So like the GNSS 7 click, it just comes up. The trickier part is learning how to use GPS in Linux.
Yeah.
And making sure the PPA signal makes it across, PPS signal, and tying all the tools with that.
Well, yeah.
One challenge at a time.
Won't open that can of worms.
Once you get it working, it works great.
All right. Well, I guess we can call this episode 1. Cyril, thank you very much for joining us. Thanks to everyone who's been listening in and everyone watching the video afterwards. See